In this video, we're going to learn how to combine like terms. So combining like terms means to add or subtract any terms in an expression that are like terms. Okay? So all of this information is in your packet. We're just going to highlight some important parts. Now the result we're going to use, this justifies how the general distributive property may apply to an example with a variable and some numbers. And the reverse direction is what we're going to use to combine like terms. So if we have an expression such as x plus 2x, we can write the following equivalent expressions. Notice these equal signs are saying that each expression is equivalent. And this is the result of the distributive property. So x, its coefficient is 1, so we could think of it as x times 1. 2x is 2 times x, or we could write it as x plus 2 because of the commutative property. Then we can write this as x times the product of the sum of 1 plus 2, and this is a direct result of the distributive property in reverse. Adding 1 plus 2 gives us 3. We now have x times 3, and we write our final result as 3 times x, which we write the 3 and x next to each other to imply multiplication. Okay. So the general result, because of the distributive property, if we want to combine like terms, we can just add the coefficients of the like terms. In this case, it was 1 and 2. Okay, and multiply the result by the common variable factor. In this case, the common variable factor was x. So we have 1 plus 2 is 3, multiplied by the common variable factor of x. Let's look at some examples. So the directions read, simplify the expressions by combining like terms. So remember, we learned that simplifying expressions means to perform any possible operations. So let's look at the first one. We have 3x minus 5x plus 6x. Okay. Well, according to the distributive property, we're going to write this a little bit different, just to sort of bypass a step. We can add the coefficients, so we have 3. Now remember, we could think of this as minus 5 or plus negative 5. You can actually, because of the distributive property, go right to minus 5 plus 6 times x. Okay, so notice 3 minus 5 plus 6 times x. Now perform the operations in the parentheses. 3 minus 5 is negative 2. Negative 2 plus 6 is 4. And our result is 4x. Okay. Now notice all of these were like terms. They had the same variable with the same variable power. Let's look at the next one. Here we have different types of terms. They're not all like terms. So let's highlight the ones that are like terms. So here, the first two terms both have a variable power of x, so we can combine these. And here, these are constants. Constants are considered like terms, and you may think of them as just numbers. Okay? And of course, we can perform 8 minus 4. So let's write our work below. Here, I put in parentheses, negative 4 minus 3 times t. So this is how we're going to combine the variable components. And here we have 8 minus 4, and I'm going to go ahead and subtract that, and the result is 4. Now negative 4 minus 3 is negative 7t plus 4. Okay. Now notice here, we still have an addition left over. We have to perform any possible operations, but in this case we cannot combine these two because they're not like terms. Okay. This term has a variable of t. This doesn't have any variables, so we have combined all the like terms we can, and this expression is simplified. Let's look at the next one. Here I'm going to highlight all of my x terms. So we have 3x plus 9x. And we have the constant terms, minus 4 or plus negative 4 and 6. Okay. Now notice these are in a different order compared to this expression. Okay? But because of the commutative property, now this is subtraction, but because of the commutative property, as long as we keep the sign in front of each term, okay, we can reorder these. So we're going to start with the 3x and 9x. It's a positive 3 plus 9 times x. Okay. Now on the right hand side, let's just rewrite this one. We have minus 4 plus 6. Okay. So subtraction is not commutative, but if we think about this as plus a negative 4, we can move that plus the negative 4 to the right and then change it back to subtraction. So that's the long justification, but basically you can think of it, you can move this minus 4 as long as you keep the subtraction sign with the 4. Okay. Now we will add the coefficients. 3 plus 9 is 12x. Minus 4 plus 6 is 2. Let's look at the next one. Okay. Here I see we have 3 different types of terms, so let's highlight them. Here's an x term. There's another x term. Here we have a term with a y variable, and then we have one constant term. So let's start with the x terms. Now this is negative x. So let's think of this as negative 1 times x. Okay, so our coefficient of negative x, remember, is negative 1. So I have negative 1. Here I have plus 7. And those are the x terms. I'm going to put plus. For the y's, I have a 2 minus 5. And the constant term is just 3. Now I'll perform the addition or subtraction. Negative 1 plus 7 is 6, so we have 6x plus, here we have negative 3y. Put that in parentheses. And then we have plus 3. Now here, notice we had a negative 3y. In general, looking up at these expressions, if the first term is negative, we write it as a negative, but any other terms where we could think of this as plus a negative 3t, we just write it as subtraction. It's simpler. So here, although this isn't incorrect, it's equivalent, we would write our final answer as 6x minus 3y plus 3. Now, all of these are different types of variables, so we cannot combine any further. Let's look at the next one. Again, I'm trying to be systematic because now we're getting more variables, so I'm going to start with the AB term. And I'm going to scroll or scan through. Here's another AB term. Okay. Now, my next type of term is 4A, so that's an A term, and here's another A term. And then we have a B term and another B term. And notice I made sure all of them are highlighted, so they're all being included in some variable category. And we'll start with the first type of variable. So this has a factor of both A and B. So the coefficients are 3, and we have minus 2, AB. Now for our A terms, we're going to put plus parentheses 4 minus 7. That's our A term. And then for our B terms, we have plus 6. That coefficient is 1, B. Now we're going to perform our additions or subtractions. So 3 minus 2 is 1. So we have 1AB. Plus 4 minus 7 is negative 3. So we have negative 3a. And 6 plus 1 is 7. So we've combined all the like terms, and then our final step, just to clean this up, it's not wrong to write 1ab, but we generally don't. We consider it more simple, and since we're asked to simplify, to just write that as ab, and this is implied to have a coefficient of 1. Again, we have plus negative 3a. We're going to write that as minus 3a, and then plus 7b. And now let's look at our last problem. First, I'm going to highlight we have x squared terms. So there's 1, there's 2. Our next type of term is an x term. So we have plus 3x minus 3x. And our final type of term are constants. Now let's start with our x squared terms. The coefficients are 2 plus 4 times our x squared. For the x term, so we're going to put a plus. Then we have 3 minus 3. And that's our x term, so plus 3 minus 3. And our constants are plus negative 5 plus 7. So now let's combine our coefficients. 2 plus 4 is 6, so we have 6x squared, plus 3 minus 3 is 0, so we have 0x, plus negative 5 plus 7, well that's 2, so we have plus 2. And now notice the coefficient of x right now is 0, and 0 times any quantity is 0. So to completely simplify this, we'd omit this term of 0x because it's equivalent to 0 no matter what x is. And we will write 6x squared plus 2. So we practiced combining like terms. In the next video, we're going to use the distributive property in 2 ways based on the other way we've learned in the other video to distribute and then to combine like terms of the result.